Using sin A plus B is identical to sin A cos B plus cos A sin B, and sin A minus B is identical to sin A cos B minus cos A sin B, which we should recognize as our compound angle formulae, we want to show that sin P plus sin Q is identical to 2 sin P plus Q over 2 times the cosine of P minus Q over 2. This is the first of our sum and product formulae. So let's start with the compound angle formulae. We have the sine of A plus B is identical to sin A times cos B plus cos A times sin B. We have the sine of A minus B, and this is identical to sin A times cos B, take away cos A times sin B. If we add these two identities, on the left-hand side we get the sine of A plus B plus the sine of A minus B. On the right we'll get 2 lots of sin A times cos B, and the cos A sin B's will disappear since one is a plus and the other a minus. The next step is to let P be equal to A plus B and to let Q be equal to A minus B. If we now add these two equations, on the left we get P plus Q, on the right A plus A is 2A, and B add minus B disappears. Therefore A is P plus Q divided by 2. If we subtract the two equations, on the left we get P minus Q, A minus A disappears, and B minus minus B becomes 2B. B then is P minus Q divided by 2. We now substitute these back into this expression. A plus B is P, A minus B is Q. That's identical to 2 sin A is replaced by P plus Q over 2 times the cosine, and B is replaced by P minus Q over 2. So we've proven the first of the sum and product identities. By a similar derivation process we can produce the following. The sine of P minus the sine of Q is 2 times the cosine of P plus Q over 2 times the sine of P minus Q over 2. For the cosine formula, we would start with the compound angle formula for cos A plus B and cos A minus B. We would produce cos P plus cos Q is 2 times the cosine of P plus Q over 2 times the cosine of P minus Q over 2. And cos P minus cos Q is identical to minus 2 times the sine of P plus Q over 2 times the sine of P minus Q over 2. This is another family of identities, and they're called the sum and product formulae.